Okay, so up first, we have a demo, Fortifying AI Frontiers, Securing APIs, the path for your AI app. So we have Abhi and Pratham here to do a demo for everyone. And let's get started.
All right. Thank you, everyone. So in next 50 minutes or so, we're going to talk about some of the key risks that we have heard from customers around AI. Then we're going to talk about what the AI workloads look like on cloud. We will go further into what some of the strategies you use to protect those workloads. We will do a deeper dive into the API towards the later half of the demo. So speaking of which, when we talk to the customers about what their concerns are regarding the AI security, overwhelmingly we hear data security, that because of this I have a chance or I have some sort of a data exposure. This is not new, has been there forever. The next big thing we hear from customers is the risks related to specifically the AI stuff. So this is where XPIAs, jailbreak, those kind of AI specific attacks come into picture. And the last we hear every now and then is stuff related to the models itself. But when it comes to the frontier model, that's not so much the case. The first these two risks, they stay common across the board no matter how your organization is actually adopting AI. That being said, so how do you protect, what is the mental framework that you can use to protect the workloads? Well, through this presentation, we are going to talk about how do you first protect the AI platform. We're going to look at then how do you protect your AI platform, because that's the gateway to your AI platform. And then the overwhelming thing, the other thing is data platform, which again, like there are several sessions around here, around that specific piece. So we are now going to go into details around data platform. So if you look at what the Gen AI Threadscape looks like currently. So you have an app or a user that is accessing your Gen AI app. In the middle, the Gen AI app is doing some grounding with the help of some data. The data can be in a storage, the data can be in a database, what have you. Then there are agents in the middle. Each of these layer, as you see on my screen, each of these layer presents its own set of unique challenges. And we need to be able to tackle all of those ones. For today, for the sake of this demo, given the time, we are going to look at jailbreak attack. So let's look at how API comes on top of it. Preetham.
Thanks, Abhi. And thank you all. And just like Abhi said, first of all, AI applications are on the rise. Like organizations are testing it, researchers are testing it. How can they productize some of these applications to intelligently build or evolve their modern cloud applications at scale, and letting other consumers, users, to use or leverage these applications across the board, right? I wanted to start with a clear, probably a real world example here. So if you see this, typically a Gen AI architecture looks like you have an AI model services deployments that are hosted behind a compute or one of the hosting environments. In this day and age, let's say containerized applications or your containerized workloads are hosting some of these models. And then to make it more scalable, they're exposed using APIs. So APIs become a critical tissue or a connectivity tissue to take these applications for external users, for partners, or any consumers who want to interact with your AI applications at scale, right? Now, one misconfigured API or a vulnerability in this API can actually lead to several adverse effects that can happen to your broader applications. One example in this I show is you have an API that's kind of guarded within the gateway or a management platform, but then when anybody gets access to these APIs, let's say it's anonymously allowed access, it's unencrypted, or it doesn't require authentication and so on, and it typically exchanges data. So when this goes into interacting with its backend environment to request, respond, any kind of information that users give, look at the attack paths that it's generating. It can communicate over network hops through a compute instance. It can then detect permissions that it has to a storage or one of the data sources. Or it can go into another account within the organization tenant and access other forms of data stores to retrieve certain information, or it can directly interact with the AI app, right? So the demo will show how exactly this happens end to end. Now, to Actually, before we get into this, right, so first I wanted to talk about why is APIs even important. So one of the first things we see is that as GenAI applications are on the rise, as more organizations are using this as the front door to or an entry point to a lot of backend applications, now APIs are rapidly increasing in number. Even more than 70% as shown here of the overall web traffic now drives API traffic. Second thing is when we think security, it's really critical because one misconfigured API or a risky API can leave the application at risk to bad actors. Leveraging some of the traditional methods, you could have a gateway, you could have some perimeter protection. They don't really have an understanding of what behavioral or what logic is this API exchanging unless you look at it in depth. And that's becoming one of the top 3 issues where if you don't have a dedicated understanding about how these APIs exchange data, then how can security teams enforce their developers, their application owners to make sure that the right security guardrails are put around their APIs. And the third thing is APIs are really becoming the most frequent attack vector. And in fact, the average API breach recently published by many analysts says that it increases by 10x as compared to any of the other average security breach as part of the industry.
So that being said, let's look at a demo. So in this case, what we are going to start with is an application that if you are writing anything in Azure Foundry, most likely you are publishing that the front end would be some kind of a web app, right? Whether it's in app service, whether it's hosted in a container. So we are going to start, and then you will access that app with APIs as well. So we are going to start assuming that an app has been published in a container and here. And then as you see on the screen, so I'm trying to do a jailbreak attack on this app, right? You saw the front end where someone tried to do a jailbreak on it. Now, that app itself is protected with Defender for AI in the background. Defender for AI picked up that it's a jailbreak attack, and then it sends it over to a Defender XDR portal, which is where you are seeing. So on the left side, what you see here is an attack story. If this was supposed to be a multi-stage attack where I did something or exploited a container-specific vulnerability, through that I did some kind of lateral movement and got hold of your AI app, you would see the entire attack story here. So here you see the attack story. On the right side, you see the details of it. If you were using Copilot, the Copilot would run on the side here and will do the annotation of that as well. This is where your SOC will start. Then going further in Defender for Cloud, now you want to see that what exposure led to this. This is where you see this path, the attack path. So here you can see this attacker, this full attack path, where you see the entire flow, where you can see now there is a container on which I was hosting the app, and this container had vulnerabilities that allowed access to my data. And you see the full path, like full application itself, and you can see that there was a storage account that was used for grounding. So I was trying to get into the application, do a lateral movement from it, and try to access your data or try to get access to your data through the application itself. You have full visibility of that through this attack path. Defender for Cloud goes further, and for doing all of that stuff, you don't need any configurations whatsoever. It goes further. And remember, we talked about the data being the biggest risks. So here, there is a pane, dedicated blade in Defender for Cloud, where you can see where the data sprawl looks like. You see what are different components of your workload, right? Are there any issues with your workload right now? All of that stuff here, so you know the first 2 big issues that customers are looking for. Is my data secure? And are there any risks specific to AI in my environment? You see that from a 10,000-foot view right here on this pane. That being said, let's look at the API on top of it now.
Thank you, Abhi. So now that Abhi showed like a typical AI application when it's containerized and published or exposed to external consumers to use, to make it run at scale, usually these AI applications are bootstrapped with APIs, and they use some sort of an API management platform or a gateway where they publish. There are 2 main benefits for this, right? So think you're a product team, you want to launch a typical pet store AI app to intelligently allow users to search for their pets, search for their profiles, make sure that they have all their pet profiles that are available. And all of these components or application abilities needs to be packaged or bootstrapped into an API management platform. Now, what happens here is, here you can go and look at one of these API which is published, and it has several endpoints, and you may have several APIs as well, depending on which application team you want. So two things are here, right? One is developers build fast. They develop fast. They want to publish really quickly to their users or consumers to get access to their applications. You have API administrators, you have your platform engineering team who are setting up these environments to make sure that they're properly configured in a way that they can be consumed at scale. In the lens of an API, you see that for your AI applications, typically how do these management platforms help us? It helps us with access, it helps us with authorization, or even like sometimes token limits, rate limits, and how do you set up certain guardrails? But that's not enough, where you need to have a good eyes-on-glass view of what's really happening in the backend environments when it comes to APIs. And this is the biggest blind spot, which leaves security teams wondering, what are the APIs exposed? How are they exposed? What kind of security controls do they have, right? So let's take an example. Here I have a pet store. I take a post request. Typically, an attacker can see that there are multiple internet-facing APIs that an organization has, and he can prompt or he can hit these APIs and see what it returns. If these APIs are misconfigured, let's say it allows anonymous access, they contain sensitive data or they're exchanging some form of data, how do security teams get this visibility? That way they can track down the right application owners or the developers to actually fix it in the code and complete this loop. So one of the ways we provide this is, for example, you see in Defender for Cloud, this is part of the Security Explorer, or we call it as for advanced hunting scenarios, where you have your applications and those applications are onboarded to Defender for Cloud. Now, as part of this, you have AI security posture management, you have API security posture management, combining these values together and giving you the ability to run some complex queries and even attack paths like Abhi showed that can help you really quickly identify, out of all my API endpoints that I have, which are the most critical ones that we need to look at it from a security point of view, and that needs to be prioritized for fixes. So here, with some quick templates that already provided, you can quickly look for your AI apps and others. But to extend this, I will show one of the queries which can give you the example of the API that was published. So here, you can see that I have my API endpoint that is exposed to the internet. It allows anonymous access. It routes traffic to a containerized workload that eventually has authentication or can authenticate into a storage account that's used for AI grounding data. And when you look at it, when you just quickly search this, from all the APIs or the list of APIs that we have, there are a few set of APIs that meet this criteria. And when we look here, I have one user like create user. So you can see the entire path it is taken and what the API is doing. In this case, who owns the API, and eventually what's the network path it's taking, which container application it's leading to, and finally showing the storage account that actually shows you the evidence that, hey, this is used, that indicates that it's being used for grounding, and what are the underlying AI resources that provide, right? So that's kind of the power we wanted to show. And